When developed and deployed effectively, large language models have the potential to increase access and quality of care. However, this impact depends on making sure that these models are safe, reliable, and useful both before and after they reach patients. One way to achieve this is through pre- and post-release evaluations. So you might be wondering, why is evaluation in healthcare hard? So models must communicate naturally with patients. They need to respect clinical boundaries. They must fit within the clinician's workflow. And that's why evaluations need to capture the complexity of your world with messy inputs and long-term outcomes. So in this talk, I'll cover how we apply eval-driven development to building Phoenix, our AI care agent, how we build and validate evaluation data sets before release, and how we monitor and guardrail behavior in production, and finally, how we use A/B testing to ensure that new iterations not only improve patient experience, but also clinical outcomes. So I'll start by giving a brief overview about Phoenix, then I'll cover why is evaluation important, and then I'll touch on the main topic of the talk, which are pre- and post-release evaluations. Okay, first, talking a bit about Phoenix. So Phoenix is our AI care agent that is built to bring clinical expertise into every interaction. It supports patients both during and between sessions. It also augments clinicians, making sure that care can scale without compromising quality. So during a session, Phoenix acts as a true companion. It greets the member, sets expectations, and follows up on previous progress. As exercises unfold, it explains movements, answers questions, and responds to voice commands. It provides real-time, personalized feedback based on motion data. Between sessions, so Phoenix continues to play an active role. It is available 24/7 to answer any question that the patient might have, and it combines health data, member context, and clinical insights to keep care personalized and adaptive. So Phoenix can, for example, recommend program adjustments, detect signs of disengagement, and prompt clinicians to intervene at the right time. So everything that Phoenix does, what it says, when it says, and how it says it, is validated both before and after release using evaluations. So why is evaluation important? So can we do like a quick show of hands of how many of you have already deployed large language models to production? Cool. And how many of you have found an issue that you have already solved in the past, and you are like, damn, I really thought that I solved this issue like 2 weeks ago? Cool. And how many of you have like received deprecation warning from like a model provider and thought, damn, now I have to validate that my agent continues to work as expected? Cool. So this is why evaluation is important. So lack of evaluations has been a key challenge in deploy large language models to production. So how can we deliver consistently without regressions? This is where evaluations become really important. So why is evaluation hard? Or why is evaluation important? So evaluation is important before release because it allows us to benchmark different models, different model versions, or different system versions. It also allows us to verify that our models or our agents or systems meet the required safety, reliability, quality, and clinical standards. And it allows us to detect regressions early and prevent them from leaking into production. So after release, evaluations allow us to verify that the model behaves correctly in real-world conditions that might be hard to simulate offline. They allow us to measure the actual impact on patient outcomes and engagement, and also they allow us to catch drifts over time, things like data or world drift. So this is the evaluation pipeline that we usually follow that starts with or is divided into two parts. First, the development cycle, and then the production cycle, and I'll cover both in detail in the following slides. Cool, so first covering pre-release evaluation. So during development, we follow an iterative eval-driven approach that starts with automated evaluation that can be both or that uses a combination of verifiable and open-ended evaluations and ends with human evaluation. So if all these checks pass, we know or we have confidence that the new model or the new agent, the new system version is ready to be evaluated and released in production. Cool, so first, covering verifiable evaluations. So verifiable evaluations are used for tasks that have clear and objective criteria. Their key advantage is, of course, scalability. Once they are implemented, they can process thousands of evaluations quickly and consistently. So, like I shared earlier, so Phoenix is a multi-agent system that needs to follow a sequence of steps and has access to tools and a knowledge base to achieve complex tasks. So we use these verifiable evaluations to make sure that the agent behavior remains consistent between different turns. So these verifiable evaluations have three building blocks. So the first one is the scenario, which basically describes the test case that we are going to verify with this verifiable evaluation, and includes external mocked data and an history of patient and clinician, history of patient and agent messages. Then the second piece is the assertion, which is basically a set of verifications that need to be compliant in order for us to validate that this use case is correct. So this can include, for example, verifications that a tool was called with a specific set of arguments, or that a tool was not called, or that, for example, the state of one of the variables in the agent state changed from X to Y. So these are deterministic checks. And then the third one is the eval suite, which is basically a group of scenarios that have the same assertions. So during development, we use existing verifiable evaluations to validate that previously implemented behavior continues to remain consistent, and then we create new evaluations that cover the behavior that we are introducing at the moment. So because large language models are, of course, not deterministic, we run each scenario n number of times, and then report success on this n number of times. So the goal is not, of course, as you can see here, 100% pass rate, because we know that the agent can struggle to perform more complex tasks. But the overall goal is for us to have like a baseline to which we can compare new versions against. So I've just covered verifiable evaluations. The other type of evaluations that we usually use are open-ended evaluations. And open-ended evaluations are suited for tasks that are more subjective and that cannot be verified deterministically. When performing these types of evaluations, we usually use another model to evaluate the outputs of the agent. And in this case, we always try to use a different model from the one that is being used by the agent, or a different set of models where the agent uses different ones, because we know that that large language models are biased towards their own outputs. So we always try to use an evaluator that's different from the core model. So when doing open-ended evaluations, the first step is to build the evaluation data set. So when we want to build the evaluation data set, a common first step is to select examples at random. This can be a good starting point, but what happens is that it results in an evaluation data set that is overrepresented with very simple use cases. So to achieve a broader coverage, what we try to do is we try to select examples that are representative of different cases. such as core cases, challenging cases, cases that are selected to stress test different components of the system, and regression tests that cover issues that were already previously solved. For new features, or when no prior data is available, or when using real data is not possible, such as, for example, in a healthcare setting, we can use synthetic data. Synthetic data also helps you to create a more diverse evaluation data set. So this is an example of the evaluation of an item of the evaluation data set that we use to validate Phoenix conversations. So over time, this data set continues to be improved with new examples that are gathered either through user feedback or through manual audit. So for each use case, we define what success looks like with well-defined criteria. So this rubric serves as a shared reference for both automated evaluators and human annotators. Whenever possible, we try to resort to binary outputs, such as true or false, or yes or no, to improve alignment. So this is an example of a rubric that's used to evaluate Phoenix and to make sure that the agent has an appropriate tone when communicating with patients. So the success of open-ended evaluation is, of course, tied on making sure that the judge evaluation is consistent and reliable. So what we do to validate that is we ask human experts, usually a clinical expert or a product manager, depending on the use case, to annotate each example of the evaluation data set. And this can be done either by a single annotator or by multiple annotators. And with experience, we always try to use multiple annotators, because this way we can measure inter-annotator agreement, and it kind of sets the ceiling for the performance of the LLM as judge. So, like I mentioned, so the items of the evaluation data set, the rubrics, and then the annotated examples form the evaluation data set and the gold standard. So once this open-ended evaluation suite is in place, we can use it to validate new versions of the model or new versions of the system. So for every major change, we use the evaluation data set, generate new outputs, and then use the open-ended evaluations to validate that the outputs remain consistent. So I've just covered automated evaluators, and the third and final step on the pre-release process is the human evaluation step. So before every major release, we run a human evaluation round to validate more subjective criteria such as tone or clinical reasoning or accuracy. So the goal here is twofold. First, validate things that are hard to validate using automated evaluators. And the second one is to guarantee that things that no unexpected issues appear that are not yet covered by the automated evaluators. So, in the same way as annotation, human evaluation can be performed either by a clinical expert or a product manager. And we usually support two types of evaluation formats, or either the evaluation can be individual, where the evaluator evaluates a single example, or pairwise, where the evaluator selects one of two possible outputs. We also have other types of evaluations, such as static and dynamic. So here is an example of a static evaluation, where you generate examples beforehand for the evaluator to evaluate. Or here we have an example of a dynamic evaluation, where the evaluator interacts with a simulation environment to validate the agent behavior. So sometimes a version might improve the automated evaluations, but fail the human evaluation. In that case, we pause the release and perform another iteration cycle. So human evaluation kind of acts as a final sanity check. So if human evaluation passes, we release the new and hopefully improved version to be validated in production. Cool. Now covering post-release evaluation. So once released to production, the new version continues to remain under evaluation. So we keep a tight feedback loop between production and development by enforcing guardrails, performing A/B tests, and monitoring through either manual audits or online evaluations. Insights from production, feedback into the pre-release evaluation, making sure that it remains reliable and aligned with real-world conditions. So the same types of evaluators that are used during development can also be used as guardrails in production. Guardrails can be constructed using verifiable evaluators. So this is an example where we implemented a guardrail to make sure that the agent message does not include prohibited punctuation, such as, for example, M dashes. So guardrails can also be implemented as open-ended evaluations using things such as using models such as, for example, GPT OSS Safeguard, which is a bring your own policy model that allow us to define specific rules in opposition, for example, to other safety models that already provide predefined categories. So when a guardrail fails, we can retry the pipeline a few times, reject the output and provide a static message, or escalate to a human. The ultimate test for any new version or any new release is to perform an A/B test. So this validates whether the new version meets the requirements that we look for. So in practice, A/B testing large language models is not very hard from A/B testing, from traditional A/B testing. You define a success metric and you compare version A against version B. However, designing an A/B test is not always, doing an A/B test is not always possible. So first, you need to convince stakeholders to delay the release to the entire population. Second, you might not have enough volume to perform the A/B test in a sensible time, right? Like no one wants to wait like 5 months to know the results of an A/B test. Then you need to make sure that the test is statistically sound, and then even if all the checks above are valid, most of the times the difference are not statistically significant. Cool. Then the third and fourth step, it's manual audit and online evaluation. So first covering manual audit. So manual inspection remains one of the highest return investments on machine learning. So by regularly reviewing production traces, we can detect new failure patterns early, understand their root causes, mitigate issues, and create evaluations that prevent them from resurfacing. To make this effective, we need, of course, comprehensive observability. So for each request, we try to capture the complete trace, which includes original inputted metadata, all intermediate model calls, tool invocations, retrieve documents through reg, and the final output that is shown to the user. So this visibility allows us to reconstruct exactly what happened in production, debug faster, and of course resolve issues more efficiently. So once observability is in place, we can run automated evaluations directly on production traces. So depending on the criticality of the issue, these automated evaluations can run on all production traces or only a subset of the traces. So for Phoenix conversations, which are conversations between patients and the agents that don't have human supervision, we usually use the same evaluation. the same evaluations that we use in development to validate behavior in production. So if pass rates drop below a predefined threshold, this creates an alert and the team is prompt to intervene and try to understand what is happening. So to summarize, so this is once again the process that we follow that starts in development with automated evaluation and human evaluation and ends in production with guardrails, A/B tests, and monitoring through manual audit and online evaluations. And this is a continuous loop that keeps improving itself. Thank you.